If you want to record it in your computer, you can request me, then I'll approve it. So somebody from the batch, you can ask me if you want to record it. I can allow you to record in your computer. Right. So today we will be extending the work that we did last time from the part 1 of this Python data wrangling to the part 2. So in this one, we will have particularly some important aspects to be discussed. All in all, it's a bit of a lengthy session, and also I have some more work to do in order to get into some of the concepts in data wrangling using Python. What I am going to do here is to first of all get a little bit of a background information, some discussion going on the hierarchical indexing and combining and merging data sets. So here's how it goes. If you go to your LMS, if I go to my LMS, I'm sorry. If I go to my LMS, I can, so here you have in your syllabus outline, you have 3 learning outcomes. So the first one is identifying data sources, types, formats, and structures. We have completed that learning outcome. By now, you should be able to understand the type of data, their formats, and their structure. And then the learning outcome 2 belongs to preparing data for analytics and apply data integration techniques. This is part of today's lecture, and we have been talking about this for the past few lectures. And then assess data quality measures. So these two go in together. And today's lecture, we will be covering learning outcome 2 and 3 both. That is data integration, transformation, and reduction. And then data generalization and summarization. Of course, we have discussed about summarization in different levels. Here also, we'll be talking about summarization as a whole. Now, having said that, when we go back, we have this hierarchical indexing and combining and merging data sets. So what is hierarchical indexing? Hierarchical indexing is the way that we organize data so that they represent different levels. So if I want to explain that, I can kind of draw a little bit of a diagram. Let me fix my set here. If I give a little bit of an intro about what is hierarchical indexing. Now, if you think about, let's say, a person, say this is the person, right? His name is John, and his age is 32 years of age, and maybe say that he's a John 32, and he likes ice cream. So ice cream. So this is a vector. This is if you think in terms of a list. This is a list. John 32 ice cream. Then there will be another person. Say this is a girl, right? And let's say that this is Joanna. Joanne. I don't know. I just put the name. Say she's 24 and she likes chocolate, right? So if you want to put these data points in a table, in a database, you will have to define things like name, age, maybe favorite food or something, right? Then you have Joan here, and then age 32 and ice cream. And then you have Joanna, this is Joan, and I say that I wrote the full name, okay? So 24, and then chocolate. So this is a list. And what do you mean by hierarchical indexing? So in the case of this type of a data frame, this type of a data arrangement, you can have levels. Like people who like ice cream can be, organized like this. And people who are in the age range of 30 to 40 maybe can be arranged like a list here. So the level comes like this, and then there is a sub level. Here also favorite food comes as a main level, and then you can go for sub levels. And also girls and boys, men and women, you can categorize them according to different levels. So when we have levels, we can have this hierarchical indexing, because it allows us to store and retrieve data in a more efficient manner, rather than having these things all tied up together. If we can organize them in hierarchical indexing order, then we can retrieve them as we want. And if you go for another example here, the in terms of numerical examples, what I can give you here is that, let's say you have two axes here, x, y, and then if you want to define a point here, you can say 3, 5. So this is a 2D array, right? This is a 2D space, and it's a Cartesian coordinate system. So you can define 3, 5, and this dot can be defined like that, and then another dot, another dot, another dot, another dot, likewise. So if you have a travel plan or something, like you went there, sort of, then all these stops and points can be recorded as a 2D point, right? So 2D point cloud. So you'll have a table where you have X and Y, and then you have these coordinates. And let's say that for each stop, you have different, like shops or destinations. For example, this can be, say, tailor shop, I'll say TS, and this can be a cafe, I'll say C, and this may be a playground, and then this may be a school, and maybe this is another movie theater or something. So likewise, you can have different names for these locations, right? So then another list may come, the location name as a new column, and you will have a list of data like this. And if you want to organize your data in a way that how many times you have visited a cafe, or how many times you have visited the school, sort of, then you can organize them in the way like school, and then how many coordinate points, or how many times, sort of. Then that is also a hierarchical indexing, because you are trying to pick the data point based on a certain filter criteria, right? So that's the idea of hierarchical indexing. Now let's look at the, give me a second. Yeah. Now, if we go to Python, so it's a feature in Pandas library. It enables multiple, which means two or more index values, index levels on an axis. And it provides a way for you to work with higher dimensional data in a lower dimensional form. So what do you mean by higher dimensional data in a lower dimensional form? It is, give me a second. Right. So hierarchical indexing and a feature in Pandas which enables multiple two or more index levels on an axis, which it's the same thing that I've been telling you. You can have a vector which contains a lot of data, and it may have different levels. So you can organize those levels, and that can be shown using a data frame or a series. I'll come to that in a moment. I'll show you how to do it. And it also provides a way for you to work with higher dimensional data. High dimensional means it's not only spatial dimensions, it can be different levels of instances, different data points, different characteristics, different things that describes a particular instance. So it can be a political ideology, it can be girl or boy, like gender, it can be age. So different levels of facets, different phases of your data, multiple dimensions. So you can look into this higher dimensional data in a lower dimensional form, because you can't always put 16 different data points and visualize it, right? It's difficult. You can only visualize maximum 3D space. 4D space is also possible if you provide some sort of a video sort of a thing that changes with time. That is the only way we can perceive 4 dimension. But above that, it's very difficult. So visualizing this multidimensional data is extremely challenging. So Pandas hierarchical indexing allows you to use a lower dimensional form to discuss about this higher dimensional data. And it also allows partial indexing to concisely select subsets of the data. We'll look into that. This means that, say that you have, as I told you, you have multiple data. In the case that I have explained, we had Joan and Joanna. So then there may be some others like Samantha or Jennifer, and then maybe Brad, or all these names will be there. Then you can kind of select and single out people who like ice cream, people who like chocolate. So you can filter them out. So that is what it means. You can partial indexing will allow you to concisely select the subsets, the parts of the data that belongs to certain levels, right? Different classes, and then plays an important role in reshaping data and group-based operations like forming a pivot table. So that's the idea behind hierarchical indexing. So we'll come to rendering and sorting levels after going through some of the concepts that I have discussed using the workbook, using the notebook. So I thought of following these commands and explaining each one of them so you can get a better idea. And then I want you to do the same exercise that I have done with your previous Python 1 programming lesson, or rather data wrangling lesson. You have to complete that one and upload it, because by practice only you will get an idea about what this is and how to do it. So I have a clear Python notebook. So I'm going to run this one. First of all, I need to import NumPy as NP and import Pandas as PD. So shift enter, I have imported this one. And I'm going to create an array of 9 random numbers and give the variable name random. So that's just because I start with simple things and then I'll go to complex stuff. So this is about generating random numbers at the beginning. So random numbers, I'm going to create 9 of them. The first command creates numpy. So np.random. Numpy.random means it generates a random number. So random n means numbers, 9 numbers, and I'm going to display that using random. So when I say enter, shift enter, I get randomly distributed numbers. So this is a normal distribution. Random n means normal distributed. I got 0.92, etc., all the way up to negative 0.00 something. So since you are now in the level, I think you are now in semester 5, I guess. So you are aware of the normal distribution. So this is a normally distributed data sets randomly sampled from that. Now this is the array, right? Now I'm going to keep that array throughout this one, and then I'm going to convert that to a Pandas series object. So I assign that object as data equals Pandas series random. So that is the part that I created. So when I execute it, I have a series. It's a Panda series object. Now observe the difference. At first, you have random number generator, random in numbers, 9 numbers in an array. Now I have a series which is indexed starting from 0 all the way to 8. So I have 9 numbers, 0 including. So 0 to 8, I have 9 numbers as a series, Pandas series. Notice that these are index numbers. If you want to refer to them, you can refer to them as using the index numbers, right? So these are index numbers. Now, I again try to change the index now. The index numbers are 0, 1, 2, 3, all the way up to 8. Now I'm going to change that index number, these index numbers, to the values that I have defined here. You can have obviously different names. You can even name this one as you like. So I can say Sandun, or I can say different names here. So if I execute this one, you can still have those names, right? So to make it simple, I'll go with the same set of values that I've chosen. So you have now, why did I do that? Just to show you that these index numbers or index values can be anything. It can be your name, as I told you, Joanna, Joan, Jennifer, or anything like that. Or it can be your a name of a fruit, something like that. Just the index values can be anything. So index, I have generated the series, p.series, put the series object, index is equal to this. Now, if you notice carefully, you can see that this is a list within a list. So index is a list. It's a list within a list. Right. Now, in the next one, I have done something. Now, let's see what happens. This is what we call that hierarchy. So like in the case of ice cream, having Jennifer, Joanna, and somebody in the column of ice cream, and in the column of chocolate, having Brad or Joan or someone. Likewise, this is that hierarchical ordering that I was mentioning. So here, if you look at this, A, so A here is a different value, another value, another value. So here, instead of having them as 3 different values or 3 different rows, they have been organized into a level of A, and then B, C, D, etc. Okay, so it's organized into the levels, and then each level will have another sub level. So 1, 2, 3, and 1, 3, 1, 2, 2, 2, 3. This is the sub level. So it can also have different numbers. Now let's see if I change this number 2 into some value, you can see that it can be changed, right? So nothing to worry here. That's the beauty of Python. You don't need to declare variables upfront, or you don't need to worry about the variable declarations, type of variables, etc. You can define them separately. So in this case, you have the level A, and then 3 different levels and values for those 3 different levels. And so this is the multi-index form. Now, if you want to look at the index, you can type data.index, and it will give you this multi-index um, pairs. So you have A1, A2, A3, B1, B3, C1 sort of. So forget about what the number means here. It's basically a pair. So you can have in the case of multi-index, you can see that it repeats A 3 times, but at the same time, it will show you the sub-levels. That sub-levels that belongs to each of the main level. So main outer level A, and then sub-level 1, so and so forth. It goes like that. So each one has a value here from the random number. So this random number series object is what I have fed into the Panda series function. Right. So notice that the pairs of the different hierarchies have been defined as a multi-index list. You can run the same command on the previous data and see whether the multi-index persists. So that means you can obviously start from here and see how it has changed. And for example, if you run this command and then see data.index, whether you get the same value, right? That's why I mentioned that sometimes the number values will vary. Okay, right. Now getting back to, you can construct the same command using a single line of code. So this is my entire command, and I have included that as a single command, and then I have shown the index as well. So it's the same thing, but the difference is obviously the values will vary here because I have generated the random numbers again. So you can obviously check that out. You can see now it's different to the values here because I have called the random number generator again. Right now, what is the catch here? We can what we need to identify here is that we can define our own series values, and we can define our own hierarchies, and from that we can actually organize data into different levels. So what is the important uh, point here in terms of data wrangling? It is that you can perform partial indexing, and then you can retrieve data from these hierarchically indexed objects. So outer level filtering starts with look at the outer level, outermost level, A, B, C, D. It's like looking at the world, the entire world. You see the globe, and when you get closer, you can see the Asian continent, Australia, Africa, China part, like Asia, for example. Let's take it as a whole, and then you have America, and then the Latin American region. So it's the whole thing. So that's the outer level that you see. A belongs to that outer level. So if I want to retrieve data from that outer level, I can easily ask to select data. So inside I put the outer level index, right? So if you want to get, this is like, if you look at the world, this is like picking at a certain continent and then asking the program to give us the details about that continent, because that's the outer level. Then if you go into the continent, you will have different countries. If you go into the countries, you will have different provinces or regions or whatever. So that is what we say from outer level to the inner level. So outer level filtering is picking up from that part. So judging from that, if you look at this code, what can we expect? We can expect that BC filtering will be, you will take B and C as a bunch. So we have asked the program to execute from B to C. Now, if I put D here, it will catch D as well, right? So these things you need to kind of understand by doing. So if I give you a exercise, practical exercise that asks you to filter out certain set of data or analyze, say I have given you a data frame that consists uh, African continent, some food related data, let's say. So I ask you to tell me whether the children in Africa are suffering from malaria or something. Okay, so then we don't know like how to relate food data to malaria. We don't know, but malnutrition or some sort of other things may be related to malaria. So you have to do the filtering at different levels, right? So you have to first of all execute a first filtering range, first filtering operation, so that you take out the data belonging to kids, and then you have to filter out certain things related to food, malnutrition or something, and then perhaps relate that to malaria, something like that. So the initial step would be to take out data from that entire set. So that is somewhat an outer layer index filtering, partial indexing. Right. So this data.lock indicates the location of the data. So I can kind of pinpoint where the data is. So if I say AC here, rather than now here, the difference is you need to put the range, right? So the ranges need to be specified here. So it goes from levels, like from A to C, entire region. You can't have the separates different blocks out from it. So you can specify that by having lock. Dot lock will give you like blocks out of it. So A, you don't need B, and then you go to C, right? So that's the difference of outer level filtering. Now let's go to inner level filtering. Inner level is somewhat it's difficult because it's like asking, looking at the Asian continent, I ask you to get the population of Western province, Sri Lanka. So it's an inner thing, right? You have to look at the Asian continent, and then you have to pick Sri Lanka, and then you have to pick Western province, right? So it's inside, inside, inside. So if I ask you to get Western province population, you have to get into that, right? So the problem here is that when you pick Western province will belong to, it can belong to many other countries in Asia as well. Maybe some parts of China will is called Western province. So we don't know. So, and that's the difficulty we find in this kind of inner level filtering. But you can see that ACD, they all have been selected because they have number 2 here. So if I say number 5, obviously I have to get an error message because 5 is not there. So if I say number 1, I will get where number 1 is in the inner range, right? So if you want particularly something, you can even go and tell that I need this, and it will be given, right? So that's about it. You need to practice on that, and you will understand how it can be used. Okay. Um, right now, the next one is about reshaping data and group-based operations. So you can use the command unstack to convert an indexed object into a data frame. So the difference between an indexed object and a data frame is that data frame, it is easy for us to look into the data frame and try to understand the relationship of data. Like in the case of tidy data, like if you remember tidy data in R, what we have identified there is that it is a way of organizing data. So when we convert a series object to a data frame, we can easily identify certain hierarchies as well as certain intersections between data. So as before I go into the unstack part, I ask you to look into the data pattern here. So we have levels, right? A 3 levels, B 2 levels, C 2 levels, and D 2 levels. And in front of each of these levels, like a pair, you have a value. So A1 negative something, A2 negative something, A3 another value, B1, B3. So each pair has a value. So if you think it as a multi-level, multi-dimensional data set, the vector is A1 negative 1.045447, A comma 2 comma negative 0.191 something, and so and so forth, right? So that is the vector. Now if I want to unstack this one, let's see what happens. So when I unstack it, it automatically has been converted to a data frame, and in this data frame the intersection shows you the thing that I was talking about. So the innermost value is given as an intersection of the outer layers. So the more you go into this one, the more intersections you will find. So if you have four data in your vector, if you had 4 or more, then the intersection of a fourth inner ring or inner level will be an intersection of 3-dimensional vector. So your data frame would look like, it cannot be shown. It has to be a list within a list. So the best that we can talk about here is this level where you have 3 data points, and 2 will define the indexing and the column, and then the value is in the intersection of the index value and the column value. So from here onwards, I guess it's easy to understand that the different hierarchical meaning will give you that intersection between columns and index. So the value negative 1.045447 is actually A1, and then negative 0.191517 is actually the intersection between A2. So the location of that data is A2. So it's easy for us to understand when we have a data frame. Okay. Right. Now let's look at this, the next one. So, when we think about unstack, it feels like we are disorganizing the data set, but actually unstack is easy for us to understand, but stacking is the way that computer understands. So there are pros and cons in these representations. The best thing that I can tell you here is that when the data is stacked, it's easy for you to look at the data as a, it gives you the feeling that data can be visualized something like this. So we have A, 1 and 2, and like this. So even if you go to multi-level, like different levels, it's easy for you to look at this. Like it's like a decision tree, right? So you have, let's say A, something, something, and then you have another thing, maybe different levels, maybe simple A, B, C, D, and then different levels. So when you go along each branch, you have a different hierarchical instance. So same here. So it's when you stack it, it's easy to understand, but unstack, like stacking will give you that order. It goes like this, it goes like this, sort of. But when you unstack it, it's easy for you to understand it in terms of an intersection, like where the values are. Okay, so that's the sorry. So that's the difference that I want to caution. Right now, that's about stacking and unstacking. Hierarchical index data frames. I can talk about this one now. Let's see. Sorry. Yeah, we'll talk about that one before going to the SAP levels. This is part of hierarchical indexing. Still, we are there. Right now, in the case of hierarchical index data frames, you have the now. Previously, we were talking about the series objects. Now we are talking about the data frame objects. So pandas data frame np.arrange12. So numpy arrange 12. So 12 data points, arrange them, reshape them in the order of 4, 3. And you should obviously have four rows and 3 columns. So let's see what we'll get. So you have 4 columns and 3 rows. Look at the indexing here. Since it's a data frame, please notice this one. I am not only teaching you how to code, I'm teaching you how to understand codes. So when you have a data frame that goes 4, 3, you have 4, 3 inner values. So this is the innermost value. So this 1, 0, 2, 3, 0, 1, 2, these are actually the key index values and the column values. So I have asked the program to develop a data frame NP arrange 12. So it's a 12 data set data frame, 12 data point data frame, and it has already automatically given index values and column values. Okay, so it's like our previous case, like Joanna, age, the age and the gender, and then you get something. So something like that, right? So you have the index value and the key, the column value. Now, when you have a data frame, you can define the index like this. So when we define the index, first goes the it's a list of list. So the 4 values that we have here comes as 4 values, and then another 4 values will define the next level. So when we execute it, you can see A has not been repeated. Okay, if here you have A, right? So this is what has happened. If I go and draw you something, to show you what has happened. Now here you have 4 index values, and then you have 3 column values, because we have developed a 4 by 3 matrix or 4 by 3 array, data frame, sorry. And then what I have given here is that I have a and A belongs to 1 and 2. I have a B, and B have again 1 and 2. So instead of repeating A for 2 times, it has developed A here and then 1 and 2, B1 and 2, in a way that it's easy for us to understand the hierarchy. So it's easy when we convert that into a data frame and look at the values like this, right? Now, here I have finished giving names to the index values, and the frame, you can see the data frame, and I can give column values. So column values are these values 0, 1, 2. Here also please notice that I have given 2 O's, 1 H, and 3 other values here. So the first one is the outermost layer, the other one is the inner. Okay, so when I look at this, the outermost layer is OH, and then the innermost layer, inner layers will carry AB, AC, and AB. Now you can see that in the inner layer of this O outer layer, the O has not been repeated, but you need to understand that this is one level. So O has AB and AC, H has AB. So that is how you identify coding. Coding of this, the structuring of this data frame. Okay, so a multi index is defined like that. So outermost layer, and then so and so forth, it goes inside the list. So you can do the same operation following a single command. So, but if I gave you this command upfront, it's difficult for you to understand. Some of you might easily understand it, but I want to show it in a way that everybody sort of get the idea. So data frame, you can first define the shape of the data frame, and then you can decide the index and the columns. So so you can name it, you can put all the names and sub levels and levels likewise, right? So why do we need to learn this one? Because you may get a data set like this. If it is a survey data set or some sort of a HR data set, it can be sales data set, because sales, obviously you have so many sales, like items are organized in hierarchical order, maybe like soap and these other items that are in sanitary category, and then maybe food category. Then you have plastic, some other categories in the shop. So, and then you have different levels, different prices, different brands, then go so and so forth. You have different hierarchies, right? So you get a data set like this. So you need to unwrap the data and then analyze it. Now, if you can define names as strings, rather than giving things like that, you can actually name the columns. So before I execute this command, let me explain you what you mean by this column. Now, if I have here, so naming the columns means I want to give a name to this column and this column. So I want to name the outermost column, outer column or outer level, I can say outer level, and then the inner level. So I want to give this as some name and this as some name, right? So when I execute it, you will find it a bit awkward. That's why I gave you some hint beforehand. Now let me execute this. See, OH level belongs to this outermost level. ABC level is this level. So you can name it anyway, right? Any way you like. So whatever the name, but the name, the first one indicates the outer level, and then sub levels will carry. Similar thing happens here as well. So outer level is AB, AB level is outer level, then 1, 2 level is this level. So don't confuse this with the other one. That's why I said you earlier, because sometimes it can be a bit tricky, because the names appear like column names, but this is not part of this. This belongs to this, this belongs to this, and this belongs to the columns top at the top. So you have the names. Right. Now, the beauty of this one is that you can select the groups of columns in this data frame. So just by executing the column name or the column name, you can actually get the value. So the OH level is here. So if I say O here, you can get the level that belongs to O. So category ABAC is extracted from the. So um, this goes like this. So O level belongs to these two categories. So I have extracted O, and AB and AC will be here. So it's a column wise operation. You have to extract all these things together. We'll talk about how to extract the row level operations or the index values as we go on. Right. So that's the part of what is multi index. So this part. So hierarchical indexing, and what do you mean by multi index? This is about that multi index part. Now, if we go to the next level, which is about rendering and sorting levels. So let me go to the rendering and sorting level. So rearrange the order of the levels on an axis or sort the data by the values in one specific level. So that means you can say now it's like moving. So if you remember, the outer level was AB and the inner level in hierarchical order was 1, 2. But now when we want to swap it, we will say sub level. So sorry, let me go to that. Now, this is where we have to be a bit careful. Now, remember that our levels A occupies the entire two levels here. 1 and 2 belongs to A. 1 and 2 belongs to B. But when we swap levels, because 1 and 2 are distinct values, you can see that there is an extra A here. Okay. So when we swap the level, there's an extra addition of A. So that's the thing to remember about swap levels. So when we talk about swap level, takes two level numbers, two or names, and returns a new object with the levels interchange, but the data is otherwise unaltered. So you can try about multiple levels and put two, but only thing you can do is like swapping things in order, because if you think about three different swapping, it's difficult to even understand. Say swapping of two values, it's easy to understand. If you swap this one with this one, yes. But if you talk about three different levels, it's if you go with this kind of an operation, you have to think about NCR, NPR actually, and then see how this one goes to this, and whether this one goes to this, and this one goes to this, or there can be other ways like this goes to this, and this goes to this, and this goes to this kind of. So it's easy to understand two levels swapping, but it's difficult to understand how or give command on how three different things to be swapped. So it's a matter of order. So in the case of swap level, you can swap only two. Now, frame sort index level 1, I'll execute this one and then see what happens. So frame is our data frame object. I'm going to sort index. So I'm sorting the index. So if you want to type this command, if you say sort underscore and then type the tab, it will autocorrect to index. So sort index means my level is 1. So here this level means the axis. So if I say 0, you can see what happens, and if I say 1, you can see what happens. So let's see the difference. So I'll copy this one and I'll where is my okay. is my command. Right. Okay. So, right. So let me copy this one, duplicate this. Right. So now I'm going to show you. Now this is level 1, and if I say level 0, observe the difference. Now in the level 1, when I ask to sort index in the frame level 1, it goes to this level, and when I ask level 0, it goes to this one. If I say level 3, you can't get a level 3, right? Because we have only 2 levels in terms of index, right? If we had more index values here, different levels, we can go to the next level, but it starts with the leftmost. So 0 is the leftmost index, and then goes as 1, 2, 3, 4, any number of levels that you define, right? Again, so these two go hand in hand. So sort index level 0 means you kind of sort it from the uh, uh, very left, the leftmost level, and then when you swap it, it's like you swapping it from this to that, and then you asking to swap it, because when you swap level 1, it's difficult to understand what has happened because this remains unswapped, or rather unsorted. So something like this. So 1, 2, it's a matter of visualizing data, and where necessary, identifying the data that you like. So when you swap it, you can kind of swap the thing and then sort it from the leftmost or the or the second level, as you like. So if I give this one to be 1, after swapping also, it will sort the same thing, but it's similar to swapping and sorting and sorting and swapping. The first one, it's the same thing, right? Okay, so that's about sorting, rendering and sorting levels. So rearranges the order of the levels on an axis or sort the data by the values in one specific level. On the other hand, sort index sorts the data using only the values in a single level. When we use swap level, it's not uncommon to use sort index so that the result is lexicographically sorted means from starting from A, B, C, D, sort of. So one to ascending order, or A to Z. It's the lexicographic means the way that you usually count, or the way that you say that it's in order. It can be alphabetical order, chronological order, whatever. So the order that you know. Right. So let's go on. Summary statistics, of course, summary statistics, you can get the summaries from different levels. So you just need to call the level. So the good thing here is that now I have used level 0, level, and level 1 as a number, but here you can actually call by the name. So 1, 2 level. Let's see if I have accurately given. This is level 1. So let's see level 1. So it's the same thing, right? So you can name it as well as give the level number. So the thing about this one is not only sum, right? You can give the direction. So axis 1 means you have two different axes here. So if I say 0, it doesn't give you a value here because the direction is only one directional. So level 1, it goes from downward direction. So because we have only one data frame direction, in like in the OH level, the data is in the OH level, the data is in this direction. So if we go to, let me erase it. If we go to let's go to OH level. So this is OH level, and the OH level is the column. So the data is organized in this direction. So the sum is 0 plus 1, 6 plus 7. So 6 plus 7, 13, 0 plus 7, 0 plus 1 is 1. So that's how it is done. So if you want to get it, you can refer to this one and then get an idea. Right, let's move on quickly. So indexing with data frames columns. Paid data frame, this is kind of the code, aggregated code, where we can define very quickly. When we want to define a data frame, you can define it from the range and frame. So I have a frame. As I told you earlier, I have a range from 0 to 9, 0 to 8. 9 is the number of data points. And then I have a 4, A, B, C, D, right? Because I have given values like A, B, C, D here, and the C, how each column would behave. So A is now when you look at this code and the other one, you have to understand that these are index values. These are index values. They have nothing to do with A here. A is defined as a separate entity. So this is a column, this is a column, and this is a column. So when you define a data frame, you are defining a column when you use a dictionary to define it. So you have A. So all of these things you should have 9 values, because you have 9 values here, 9 values here, 9 values here, 9 values here. If you don't have a value, you have to at least put an n, not a number, because otherwise you can't construct this type of a data frame. Okay, so that being said, so this is the indexed data frame that I have created. Now I'm going to do something here. Frame 2, frame set index CD. So set index will allow me to set an index. So I'm going to create a frame 2 using frame, the first one that I created, first data frame, and set index CD. So let's see what will happen here. So in the case of C column, I have taken C column and made it the index. So please, if you are trying to get a note here, I have made the C column an index. So I have defined this one as this, and I made this one as the index. So I have kind of put it here, and then I have made this column as an index, and then I have made D the sub level of C. So I have made C as the index, and then I have made D as the sub level of this. So that is what we have to understand here. So you have different levels just by taking the data that is there. Right. So then obviously the other data points will carry on, because they are just numbers, and these are kind of the things that I have defined. So based on the levels are defined, and then that goes on. So frame 2, again I'm setting the index, but this time I'm making this drop equals false, because as you can see, I have let me try this. So I have sort of taken C and D here, and then in the first code, C and D has been removed, because C and D have become index values. But rather than keeping that way, I have kept C and D values here. So that is why drop equals false is there. So after doing this one, I'll give you like 5 minutes break. You can have a rest and come 5 minutes. So let me do this one as well. So once you set index, you can reset the index. So when you reset the index, what will happen is basically whatever came here to be the index will go back and restore the original data frame. Okay. So what are the applications of these things? We'll talk about that in like 5 minutes. You can take a break, and I'll start the lecture. Now it's 2 2. Round 2 8. I will start again. If you have any question, please ask me. Okay, so I am back. Now, the next part is about the combining and merging data sets. So where we were, you have all, I'll upload the lecture file PDF so that you can look at the other functions available for the aggregation and indexing with columns. We have discussed that. Indexing with the data frames columns. We have discussed that one. So combining and merging data sets. So it's a similar process to SQL commands, the relational databases where we can join data sets. So when we join data sets, the join operation, we need to join using index values, right? Otherwise, there is no meaning. If you join two data sets that don't have a connection, then that's not going to work. So the join operation will have one to one, one to many, many to one kind of relations. So that's why it's a relational database operation. It's a join command. In the case of pandas, we call it pandas merge. And then you have, when you need to stack together objects along an axis, we do it using pandas concat. So concatenation, if you are, I think you did Python in the first maybe second semester or something. So concatenation is the combination of text. So if you want to say add two text values, you can go to concatenation, then concat will do the string operation of combining the things. So similarly, we just stack them together using pandas concat. When you want to slice the overlapping data to fill in missing values in one object with values from another, combine first can be used. So we'll look into these things as we go along. So joins, I will go to joining two database. So I'm going to create two data frames, data frame 1 and data frame 2. Data frame 1 is a pandas data frame. I have given a dictionary. So if you remember, a dictionary gives you a column. The first one is the key. So I name the dictionary, the first column as key, second column as data 1, first column as key, and second column as data 2. So if you carefully notice this one, you can see in the key column, I have A, B, B, B sort of. And then in the second data frame, under the key column, I have only A, B, and D, and some three values uh, to fill that. Right, when I create that, so I don't see the data frame now, okay? That's why you have to understand how this works. So I don't see the data frame. But I know that the first column belongs to it's the key, second column is the data, data 1, and the second data frame also has two columns. The first one is key and the second one is data 2, right? Now if I go to without visualizing, if I go to merge, so this is how it looks. So if I want to visualize it, I can run this one and see how df2 looks. But just keeping that in my mind, I have key one, the first one, key is this, and data 1 and data 2 has been merged, right? They have been merged, and as you can see, there are no 4 columns. We merged 2 column data sets, but we have only got a 3 column data frame. These are index values, right? So why do we get these 3 column data frame? It's because key, as I mentioned, key, it merged the data frame using the outermost column. So the first column, key is my first column, key is my second column, and it merged is the first column of my second data frame. So the merging operation has connected the two databases using the key values. So if I say A, B, D, now this is how it looks like. So if I want to show you in terms of values, so this is my data frame 1. So this is my df1, and df1 contains key and data 1, whereas df2 contains a key, the same name key, and data 2. So this one has the same characters as this one. So it goes A, B, B something, and this one only has 3 values. A, B, D has to be this, right? And this one has multiple values. So what can we have, what can we imagine from this one? df1 can be something like entry. So you are entering to, so this may be a company. So df2 may be something of a directory. So key may be the name or the index number, say your index number 11 something. So the index number is there, and about you, the name and the mobile number may be here, and the df1 may be the entry to a location. So you just swap your card, or you open something, you go into that shop or that laboratory or something. So your name, your index number, and whether the time you have entered, your index number, the time you have entered. Likewise, this may be that database. This may be your index number and your data, your telephone number. So by merging, what has happened here is that the index number part has been merged. So the key column here is the merge operation of the index number, like in the case of A here. And then data has been merged following this one as a key. So following the key value as a key. So your index number is here, and your contact number or the time you have in. So data 1 comes from this one. So the time you have entered a certain laboratory will be here, and then this may be your contact number that comes from the other table. So merging operation simply did many to one or one to many operation there, because that is what we are interested. So at the end of the day, you will be getting a database which contains like your many to one join. So many to one join will give you the data about your entering to a lab and at what time, what number you should call. That's just an example, okay, just to give you an idea how to use this merge command and why it is important. Right now, when we follow that, you can now here pd merge, I have given something called on equals key. So when I did that, let's see what will happen. And the same thing, key goes like that, and data 1 and data 2 goes like that. Nothing has changed. So if I don't specify which column to join on, so if that information is not specified, merge uses the overlapping column names as the keys, as the key values. So it's always good to keep this on, because if somebody else is going to look at your code and try to understand what has happened, that person doesn't know how the merging operation has happened. So as I told you, the merging here occurred because A and A, B and B, they overlap. So the program automatically merged them. But here we have specified that the merging has to be done using key, right? So that's what you have to say. Now, if I say, let's see what will happen if I say data 1 as my merging operation. If I say data 1 here, whether it's going to merge. It's not going to merge, because the values that if you go 1 to 1 can only be merged following the overlapping values, right? So that's why it appears like that. You have to check that out. Right now, let's go into df3 and df4. These are new data frames, 3 and 4, and I'm going to merge them using the left key and the right key. So left on and the right on. So this is how it looks like. So what happens here, if the column names are different in each object, we can specify them separately. So in this case, the left key and the right key, they have a list here. and you have data, and also data true comes from the dictionary that has 3 range values. So I am asking left on starting from this key and the right on starting from the right key. So I'm forcing the program to merge them using the left and the right. Like it's like this. So if I draw it this way, the DF3, it looks like this, and the L key is here, and it has different values, and DF4 is the same, and the right key, so R key, obviously, even though it is R key here, it's the first column here, so it has A, B, C, and so forth. I am forcing to check R key and L key in merging operation. So I'm asking to merge this one as L. So L key B merge with R key B, and L key B, so B to B, B to B, A to A, and A to A. So I'm keeping them separated rather than having now, previously, if you remember, from 2 columns, we got 3 column data frame after merging. But from here, from 2 column operations, we have got 4 column merged data frame. That's because we have forced the left on and the right on while doing the merging operation, right? Rather than doing them separate, like keeping them merged, I have asked them to keep them in the merged list. So that's what has happened here. So these are the things that you have to actually understand. These are the parts that you have to understand when you are answering questions, particularly like how this type of a code will behave, right? Now, PD merge DF1, DF2, how in the outer. Now let's go to the presentation. We talked about this one. If column names are different in each object, you can specify them separately. Yes, we did that. DF joins, right? C and D values and associated data are missing in the previous result. By default, merged as an inner join. The keys in the result are the intersection. Other possible options are left, right, and outer. The outer join takes the union of the keys, combining the effects of applying both left and right joins. So we'll come to that. What do you mean by outer join? What do you mean by outer and what do you mean by inner? Let me come to that. Data frame. I'll show you some outer connection here. So these are the 4 operations: inner, left, right, output, and outer. So outer starts with this outer, inner, left, right, and output. So outer one is given here. What happens there? So if you have a column that has L key and R key, so outer is an operation that you kind of put the key and then do the merging. That's the outer one. So let's look at the other aspects of it. So how outer? So PD merge, when we say outer, rather than having these 4 columns, now DF1, DF2, let's see, DF1 and DF2 are these things. So on key, the out operation is here. When I say, let's say DF3 and DF4, if I say that, let's see what will happen. So it cannot be done because the LK and R key are 2 different names. So you have to go with, first of all, what you have to define what that column is. Now let's see whether we can follow that. Right. So this is what happens. Right. So when you do the merging, you have to specify which columns are the interested columns, and then only the merging operation will happen. In the case of outer and inner, so if I say inner, What's the difference? So in the case of R key, so in the inner operation, that's the typical one, say left. So now there's a difference. That's the difference. You have L key and R key, same thing. The merging, particularly at this point, you have C as L key, C as L key here, and here in the typical operation, the C was not there because there was no R key here. So it starts from the left, operation starts from here, from the L key. So the operation started from this column. If I say right, you should see that ABD will be mapped rather than the other things. So you can see AB, yeah, because D comes from here, D is not there. So it's starting from the right side. So from the other side of it. So the second column, right? So that's the difference between left and right. If I say left, you can see that the C is there, but C is not there. But if I say right, D is there, D is not there. The other way, D is there, but D is not there. Right. In the inner case, it's easy to understand because that when there is no data, so it is not capturing. Now, how do we ask questions from these type of things? When you have a database, now these are some. When I teach practically, but when we think of this one as a theoretical thing, now if you have an intersection of something, if I now this is a question I ask from you. Now, if I have something, some intersection, say that A intersection B will have certain columns, whereas A intersection B prime will have some columns. And then I can ask a question, if I run this command, which columns will be there on the merge data frame? So what are the columns? What will be the columns that you can get by doing this operation, right? So if I say how as inner, you should be aware that inner only takes the intersection, right? So A and B, when they are there, it will automatically take that. And also, if I say left or right, you should be, you should know that if I say left here, even though some value on the left side is not available, that will be merged to this list because the left side is the merging pattern, like how to be merged from the left side. Okay, so this is how the questions can be formed. So that includes how you understand the data wrangling task. All right. So be very careful because in the practical terms, you have to think in terms of the logic, how to do and how to get the certain merging operation. Right. So that part is done. So there are different joins left, data frame to be merged on the left side, data frame to be merged on the right hand, how inner, outer, left or right defaults in on columns name, blah, blah, blah. So you have some stuff here. Right. So I can stop here and I will put some assignment in the Moodle. Please be cautious about that. There are some parts that I have to do again, like some concatenating and reshaping hierarchical indexing. So I think for today, this is enough. I sort of thought of finishing this one. So I'll upload, same thing, I'll upload the PDF of this one. So I'll upload the PDF of this one. Please do the same thing that you have done with the other one. Take this one and do it by yourself, and then please upload it to the Moodle. this is just not in a way that I want you to do work or something, but unless you do this one and practice, you will not learn. So then there is no point of learning this particular subject, right? So I want you to learn and learn it to the best you can, so that you can apply that into whatever the thing that you are going to do. So I'll upload both of these files similar to the previous case. Upload the worked file, like the executed file to the Moodle, and I'll upload another work for you to another assignment for you to do using these few operations that we discussed, sapping, including this and that. It will be sort of an individual work, so you can get a data set and do these operations, and I'll define what to do and I'll upload. And then please visit your Moodle and ask your friends who don't come to the lectures to visit the Moodle as well, to get some idea of what is happening here. Okay, so we are actually getting very close to the end of the semester. So by the end of the semester, you should be able to identify data sources, types, formats, and structures, prepare data for analytics, and apply data integration techniques, and assess data quality measures. So this is the whole point of data wrangling class. So can keep that in mind. So I'm going to stop the lecture for today. We'll meet next week for sure. But please keep your eye on the Moodle, because I will put some work in the Moodle in the coming days. All right. So if you have any question, you can email me and ask me where necessary. I got some emails regarding Power BI work, some sort of a thing, but I couldn't find time to respond. But I'll respond soon. So anybody who has some some concerns or something that would like to discuss, you can put me an email, and I'll contact you later. All right. So I'm going to stop. Bye.